In this video, we are going to learn about Fibonacci retracement levels and how to code them up in Python. If you are making a trading bot or you are doing automated trading, you can use these to place limit orders at the Fibonacci retracement levels using the code that I am going to show you. The download link to the notebook will be in the description below so that you can use this code and improve it as you want. In this video, we are first going to talk about what is a Fibonacci retracement level and why does it work, and then we are going to look at a Python code which will allow you to construct these levels as I'm showing you here. So let's first learn what is a Fibonacci retracement level. This is a picture that I got from a website here called Baby Pips, and I will link it below so that you can learn more about Fibonacci retracement levels from here. But basically, the idea of a Fibonacci retracement level is that the level works in a trending market. So here you can see a strong uptrend in a market, which is the Australian dollar versus the dollar. And then once this uptrend is completed, there is a downtrend, but then after the downtrend, there is a reversal of this downtrend. So at some points like here, the downtrend reverses, right? And the Fibonacci retracement levels say that there are certain sort of psychological levels at which the reversal happens. So one, it works in a trending market, and B, it basically helps you find those levels of reversal. So what you can do is place a limit order at the Fibonacci retracement levels if you are sort of going long, and then you are guaranteed that, or the hope is that it retraces back at these levels and the limit order leads to a profit. So now so there are two different steps. The first step is to say that how can we detect a trending market or a swing in the market? So only if there is a swing in the market, then we are going to look at the Fibonacci retracement levels. So our step one is going to be an algorithm to detect a swing in the market, which is to identify points such as this and this. And the second step, once we have done that, is to calculate the Fibonacci levels, which is these lines here. And we are going to see how to program those two steps in Python. So let's look at step one. So here we have some price action from Bitcoin. And what we are going to, and we have the candlestick patterns, but along with the candlestick patterns, we have plotted in this blue line a 20-period SMA, or simple moving average. Now, based on that, we are going to define a swing detection algorithm. Our swing detection algorithm has two steps. We want the price action to go from bearish to bullish. And our definition of a bearish price action is when the price is below this 20-period SMA. And our definition of a bullish price action is when the price is above the 20-period SMA. Let's look at an example here. So this is a region where the price action is bearish, and you can see that the price is less than the 20-period SMA. Now, this region here, the price is bullish, and you can see that the price is above the 20-period SMA consistently. So we want to see a crossover from the price being below 20-period SMA to the price going above 20-period SMA. So that is step one. The second sort of criteria that we want the swing detection algorithm to satisfy is that the price change should be more than 1% between the bearish and the bullish regime. So we include this step because we don't want to calculate some of these fake swings like this one, for example, which is too small. We want to see a large swing which will confirm that the market is trending in either the upward or the downward direction. We're going to take long trades, so we want a swing. We want to detect a swing in the upward direction, and then we want to place our sort of Fibonacci levels like somewhere here or here. Like I'm just drawing some random levels now, but our algorithm will sort of decide them. And then we are going to see, we're going to place limit orders, and then hopefully the price reverses from these limit orders. Now let's go jump to the code and see how to do this in Python. So we start with the conventional data set that we start with is Bitcoin data at a 5-minute interval. So you can see that the data is at a 5-minute interval here, sometime around July 2024. So now let's look at this small sort of part of this data frame, which we have, which starts at the 2400 sort of index, and then we look at sort of only 500 data points so that the visualization is easier. So first we calculate the SMA, and then we plot the price action, and we plot the simple moving average with a 20-period simple moving average here. Now we define our algorithm to detect the swing. How do we detect the swing? So our algorithm says that we need to find the crossovers. So at first we say, is the price above the SMA? So if the mid of the price is above the fast SMA, we define a column called the above SMA, which is true or false depending on whether the middle of the candle, which is the average of the open and the close. So we define the mid as the open plus close divided by 2. And if this is above the fast SMA, which is a 20-period SMA, we say this column is true. And then we shift it by 1, which means that was it true in the previous candle? So was this above the SMA in the previous candle? Okay. So and then there is the one sort of nuance is that the first value is 0 because we are sort of calculating what happened in the previous candle. So for the first candle, there is no previous candle. So that is NA, which we want to avoid. So we fill that up with a false. And now our crossover starts when the previous candle was above the SMA, but the new candle is not above the SMA. So this is when the price goes from a bullish to a bearish. So this is the start, goes from bullish to bearish. Okay. And then this is when the opposite happens, when previously it was above the SMA and now, sorry, so now we want to detect two things. We want to detect the start of the crossover. This is when the price goes from a bearish to a bullish regime. So this is the start of a uptrend. And we detect that because for the previous candle, the price was not above the SMA. So not above the SMA on the previous candle and above the SMA in the current candle. And finally, the end of the uptrend happens when it goes from bullish to bearish. And this happens when the price was above the SMA in the previous candle, but is not above the SMA in the current candle. Was above the SMA in the previous candle, but not above the SMA in the current candle. So we want to detect these two levels. And we say that the price change threshold in the swing should be above 1%. So now we iterate through each of these rows in the data frame, and then we say if the crossover start is true, then just record the start of the crossover, the location index, and the value. And then if the crossover end is true, and then we record this. So now if we recorded an end value here, and if the start value is not none, so there is a previous start value. So initially we initialized both the start value and the end value to none. So now we've detected an end value, which is when it crosses from bullish to bearish. And if there is a previous start value when it went from bearish to bullish, then we have successfully detected a swing if the price changes above the threshold, and we sort of record that swing. So just to give you a visual example, this is a visual example here where this is the start of the swing, and this is the end of the swing. And again, this was detected purely automatically by Python. There's no manual work here. So it detected the place where the there was a bullish price action, because this is where the maybe I'll show you in a plot. So the algorithm first says, is there a place where the price goes from below the SMA to above the SMA, and it says this is the point where that happens. And clearly that is, visually we can see that. So it detects that point, and then it detects this point here where it says the price went from above the SMA to below the SMA. And then it says, well, now we have detected this point. Is there a previous point where the crossover start is there? Which it then says, yeah, there is a previous point where the crossover start is there. And then it asks, is the difference more than 1%? So let's go back to the code here. It says, is there a crossover start, which is not none? And then it asks, is the price change? It calculates the price change, and it asks, is the price change above the 1% threshold? If so, it detects it as a swing. So that is the first part of our algorithm, which is a swing detection algorithm. So clearly you can see that it has detected a swing. It's saying that this is where the swing started, and the 62,852 was the price when the swing started, and the index where the swing ended was 2581, and 65,113 was the price then, and there is a 3.5% change in between when the swing started and ended. So we are now certain that we have detected a swing. So the next part is to find the Fibonacci retracement levels, and this is the easy part. So now that we have detected the swing, the Fibonacci retracement levels will say that, well, when the price goes down, when is it going to come back up? So to calculate that, let's look at the first swing. In this case, there is only one, but it was a list. So we're looking at the first swing, and then the start of the swing is the starting index of the swing, and the end of the swing is the end index. And then we define a small sort of data frame which contains only values between the swing start and the end. So we're saying that the location index should be larger than the swing start and less than the end of the swing. And then we find the range here. And the range is basically the range of values between the start and the end of the swing. So between somewhere here and here. And then once we've defined that range, we're going to find the width of that range. And then the Fibonacci retracement levels are sort of, they are predetermined levels like 50%, 61% based on the Fibonacci sort of series. And these are retracement levels where we believe that the stock will sort of reverse direction. And then we just calculate all these levels in a list by using Python's list comprehension, by going from the minimum of the range and then multiplying it by the percentage of the Fibonacci levels. And this is sort of these are known values from the Fibonacci series. So we just wanted to confirm the min max, and they are within the range that we expect. So it's between 62 something and 65 something. Okay. So now finally we plot the Fibonacci levels, and we observe that so we plot the candlestick patterns, and then we look at each of the Fibonacci levels and we plot a horizontal line at the Fibonacci levels. And finally, let's look at whether the price action is actually respecting these Fibonacci levels. So if we look at the plot, a zoomed in version of the plot, we can see that this is where the retracement starts. So the retracement sort of starts here, and then we see that there are sort of small reversals at the points indicated by the Fibonacci levels. So this is a small point where there is a small reversal of the trend, and then there is a large reversal. If you placed a limit order here, for example, you could have sort of caught this reversal and easily exited at a profit. And then the second time it sort of respects the same level here. And there are multiple other examples. For example, this is another Fibonacci level which is respected, and then the stock sort of goes up from here. So the idea is you place limit orders with these small sort of take profits here, and then you know that the Fibonacci levels will be respected and there will be small sort of upturns in these levels, and you go long and you take profit at the next Fibonacci level. And again, it happens multiple times. So here is another example where sort of it goes, the stock is steady here and then it sort of goes up again. And finally, I think the biggest one is here where it sort of respects this last Fibonacci level and it goes up from here. So one personal sort of anecdote is that I was initially not a big believer in Fibonacci levels because I think they are pretty arbitrary. But I think the reason that they work is because of like a herd mentality or a psychological effect. A lot of traders and a lot of automated softwares use these levels, which means that a lot of people are placing limit orders at these levels, which causes the market to reverse at these given levels. And then you can sort of take advantage of that. But it doesn't mean that there is anything inherently special about these levels, but I think it works because of sort of a more psychological reason. So that was my presentation about the Fibonacci levels. I hope you liked this video. Please like and subscribe if you want me to make more videos about automating trading strategies in Python.